All right, so this problem number 3 is an impulse equals change in momentum type problem. Today I'm going to talk, after I go through these, I'm going to talk about conservation momentum, but then I think the problems today still relate to impulse equals change in momentum. So in this particular problem, it says Jerome plays middle linebacker for South's varsity football team in a game against crosstown rival North. So it's sort of a pain that they use North and South, and then the runners are going East and West. So the North and South are not important here. It's just the name of the team. The team could be anything. So rival North, he delivered a hit to North's 82-kilogram running back, changing his eastward velocity of 5.6 meters per second into a westward velocity of 2.5. Now what you will find is that it's a greater change in velocity when there's a change in direction than when you just stop something. So if something just stops, that's a smaller change in momentum. So in this problem, we want to determine the initial momentum of the running back. Now, the way to do this is we can use still O and F for original and final. Sometimes you're going to see, especially with momentum, that we use primes. We use, like, sometimes you will use PO and PF, and sometimes you will use P and P prime. And what the P prime stands for is after collision. So this would be the momentum before collision, and this is the momentum after collision. Once we start dealing with more than one object, then we usually use this instead of this, because I now have to identify the momentum of one of my 2 or 3 objects from the momentum of the other. So we use prime. For this problem, because they are saying initial or original, I'm going to use this right now. So I'm going to use PO. So if I'm solving this problem, part A, I'm solving for the original momentum of the running back. And the reason why I'm going to use PO is if you look at this, all of the questions have to do with the running back, the running back, the running back, the running back. So we're only talking about the running back. If we were talking about the linebacker who's hitting the running back, then I would probably use the primes, because I'd have to use P for running back and distinguish that from P for the linebacker. But in this problem, we only have one person we're looking at. So the original momentum is going to be the mass times the original velocity. So the running back, in a game against he delivered a hit to North's 82-kilogram running back. So the mass of the running back is 82 kilograms. And changing his eastward velocity, so to begin with, he's going east. Now normally, just like other problems we've done, if you look at a compass, north is up, east is right, west is to the left, and south is down. So east will be our positive direction, because if it was a graph with the origin at the center of our compass, then east would be to the right. So I'm going to say that that's a positive 5.6 meters per second. And since my answer will come out positive, then I know that the original momentum is to the east, east being positive. So you can just leave it as positive, and you can write the word east if that's what you want. So what do I get if I multiply 82 times 5.6? 459? So 459 kilogram meters per second. And since they are using east and west, you can either leave it like that's correct, to just write it like that, or you can say east. Now, I used a different color here. For the momentum, it says determine the final momentum of the running back. So the final momentum of the running back is going to be the mass of the running back times the running back's final velocity. So it's going to be 82 kilograms times the final velocity. Now, the running back literally got hit and went backwards. So change direction. So that 2.5 you have to write as negative 2.5 meters per second. And so if you solve that, the answer comes out to be negative 205 kilogram meters per second. And the negative means west. All right? So you can just leave it as negative. You don't have to write the word west because negative to me would tell me that that means west. If they're giving me directions in terms of east and west, and one answer is positive and one's negative, I know the positive is east and the negative is west. Now, it says determine the momentum change of the running back. So in this one, the change in momentum of the running back. And again, because all the questions have to do with the running back, I don't need to use subscripts. If I had to answer a question that had to do with the linebacker, then I probably would use, I'd probably write an R down here or an L, depending on whether I'm talking about the running back or the linebacker. So in this one, it's going to be, now there's two ways of getting it. We can get it from the mass and the change in velocity, or we can get it from the final momentum minus the original momentum. Both of those are going to give me the same answer. Now, since I just solved for the final and the original, I think I will use the second one here, but I'll also do the first one just to show you we get the same answer. Whoops. So that's going to be the final momentum is minus 205. You have to put the sign in when you put this because momentum is a vector quantity, and so the sign matters. So, and the original was 459. And so that's just going to give me a bigger negative number because I'm starting negative and then subtracting from that. And so that answer comes out to be, should be negative 664. Now, you could have, like I said, you could have used 82 kilograms times the change in velocity. So the change in velocity, I'm going from positive 5.6 to negative 2.5. So my change is actually going to be negative, from positive 5.6 to get to 0, I'm going negative 5.6, and then 2.5 more, that's going to be what? Negative 8.1 meters per second. That would actually be the change in velocity because I'm starting at 5.6 and I'm ending at negative 2.5. So think of a number line. I'm to the right of the number line here, and so to get to 0, I have to go over negative 5.6, but then I have to go 2.5 more to the left, which would be negative 8.1. So if I multiply these two numbers together, I should also get about 664, negative 664. Anyone do it this way? You want to put the numbers in just to see if I am right here?
That's right.
Okay. All right, so there's your answer for part C. Well, for part D, determine the impulse delivered to the running back. Well, impulse equals change in momentum. So in part D, I know that impulse equals my change in momentum, and I just solved for my change in momentum for the running back, so that has to be the same answer for the impulse, negative 664 kilogram meters per second. So those are your answers. And notice it's in an organized way. I know because we're dealing with different momentums here. So it's very important that you put the correct subscripts and things like that. And like I said, this problem only dealt with the running back. If we were also dealing with the linebacker, we'd probably have to know what the mass of the linebacker was, and then we could then figure out actually how much his momentum changed. Because when he collided with the running back, his momentum is also going to change. All right, any questions with that?